Yeah, Mr. War here. That's right. What's up? It's another fun-filled day in Videoland, and we have our alien friend. How nice. Welcome aboard, my friend. My goodness, what a wonderful day for math. Here we go. We're still on our same topic. Topic B, making like units pictorially. We've been focusing in on that. And we also have our objective here. Our objective is really clear. It says that students will be able to subtract fractions from numbers between 1 and 2. That is our goal. Let's go ahead and move on to that. Here we go. Oh, look what we have here. Exciting. Ooh, the Medina family. Woo, people we know? I think so. So let's go ahead and read the problem. Again, we're focusing in on our RDW. If you recall, the read, the draw, the write. So here we're going to go ahead and read. And the problem says here, it says a Medina family combined 2 bags of dry cat food in a plastic container. Okay. And it says here that one bag has 5/6 kilogram. And it says the other bag 3/4 kilogram. So the units are the same, kilogram. That's good. What was the total weight of the container after the bags were combined? This is letting me know addition here. Okay? Looking at this, the first thing that I want to pay attention to is this fraction. And I can see that those have been divided into 6 and these have been divided into quarters, and that's a problem because we can't combine, we can't add fractions that have unlike denominators. They need to be the same. You can see our area model down here below. Our area model represents, we have sixths and we have some quarters here. I can show this quantity in quarters, and then I could show that one in sixths. Well, since I need 5/6, I think I have these already prepared. I'm going to go ahead and just kind of open this up. Woo, little big. Shrink. Yeah, something like that. Close enough. Yeah, ooh, I didn't know he was coming off. There we go. So that shows our 5/6 right here. And then, of course, over here, we're going to open this up. And isn't that something? Yeah. So now I have my 3/4 and I have my 5/6. I've actually shown this on the 2 area models. Again, this represents my fractions. However, it doesn't make it easy to add. As you can see, this one here is not the same size of those. But if we were to transpose these on top of each other, you can see that we can. If we were to take those 6 and those quarters, that we could get 24ths, which happens to be the 2 denominators multiplied with each other, because the 4 times 6 does equal 24. So what I want to do now is I want to take this and bring that down like such, and maybe a little bit higher so I get my 5. The same with here. Now you can see we can add these 2 together because they do have the same units. So here, what was at one point 5/6 is now going to be equal to 1, 2, 3, 4, 5 times 1, 2, 3, 4. So I can find that out. 5 times 4 is 20. So now I have 20 24ths. And as this was 3/4, now is equal to 1, 2, 3, 4, 5, 6 times 1, 2, 3. Now I have 18 24ths here. And you see we're adding these together. But now we have 2 equivalent fractions that we now can add together. This particular problem is going to bring us more than one whole, because if you think of it this way, a whole on this problem is going to be 24 24ths. We have 20 here, which is 4 more spots here. That would give us our 24, giving us our one whole. And we could take those 4 from the 18 over here and just kind of add them there, and then we could say we have 1 and 14 24ths, or we could write and go ahead and add our numerators together and then do it this way. So now here you can see the 24 and 24, we definitely have one whole. So let's write it this way, 24, 24, and then we're going to put plus, and that's going to leave how many here on the top? 14 24ths. See how that's going to equal the 38 24ths? So now you can see we have one whole, and I'm going to bring this down here. Let me go to this. I think that'll solve the problem. So I can extend the page here. Yay. Okay, now we can take our 24 24s, which is equal to 1. And then we have our 14 24s. And that would be our answer. Now we can put this in simplest form. We're always looking for common factors for the numerator and the denominator. We could reduce this fraction because 14 divided by 2 is 7, and 24 divided by 2 is 12. So we'd have 1 and 7/12, and that would also be correct. So the container then of the dry cat food combined would be 1 and 14 24ths, or 1 and 7/12 kilograms. That unit of measure on there in the end. Okay? On to the next problem here. Next page. Here we go. Now we have 1 1/3 minus 1/2. Okay, we are subtracting now at this point. So let's go ahead and represent this. Here's our pen. So 1 1/3. Well, here's 1 whole. I need thirds. I guess maybe I'll come over here, and I guess these lines are here for a reason. Here we go. Because with those two, I can make 3 equal parts. Here they are. Okay, and I'll get my pen. Now I have 1 1/3, so I'm going to just do, that's not what I want to do. Let's try that again. Okay. 1 1/3, here we go. That shows 1 1/3. And now we're going to be subtracting 1/2. Well, this is where I'm kind of come down below and show it this way. Get 2 more of these here. So, come on down. I can't reach it. There we go. So looking at this, 1 1/3 minus 1/2. Well, I really can't subtract a half from thirds because thirds and halves are different fractions, and it makes it really, really difficult to take that 1/2 and subtract. However, if I were to take what I already had, and let's just say, let's make this make everything into thirds. Ooh, that didn't work out. Shrink you down a little bit there. All right, and I'm just gonna make a copy of you and move you over here. I have the same amount here, and I'm still showing my 1 1/3. Here we go. Might have to shrink it down a little bit. You know, I'm gonna do the same thing for this one here. Get that off. Thank you. Perfect. Okay, so now that way I can make this a little bit larger, and I can extend the page if I need to. So now I have my 1 1/3 here, but I'm showing everything here in thirds, and I'm going to go ahead and do this and break this in halves. Same problem, haven't changed anything, but by putting in halves now, I can look at this and say, okay, I still have my 1 1/3. Now to subtract the 1/2, a couple ways I could do this. One way is, well, if I'm going to subtract 1/2, I could think of it as that, well, I'm going to just take that half right off of the whole that we had. And I've taken a half because that is a half. And I can look at 1 1/3 because really what that is that is 6/6, which is 1 whole, and then 2/6, because you can see that 1/3 would be 2 of these. And what I could do is I could take the half off here and then turn around and then just add these 2/6 with what was left over here. And now you see we have 3, 4, 5, which would be 5/6. Okay, that's kind of one way we could solve this. Now I'm going to do something here really quick here without extending my page. Let me see if I can be successful at this. Now let me see. There we go. So I'm just going to shrink this down here to get it out of the way. And what I'm going to do is I'm going to make another one. And kind of think of doing this problem in a different way rather than taking the whole. So taking a half from the whole. Okay. And I'm going to get my half in here. Get my half here. Okay, so now we have the same problem here. And this representing the 1 1/3. But instead of taking the half straight away, what I could do is just turn all of this into 6 first. So 1 1/3 we said was 6/6 plus 2 over 6. Well, that gives me a total of 8/6. Okay, now I can take my 1/2 and look at my 1/2. What does my 1/2 equal? 1, 2, 3, it's actually 3/6 because 1/2 is equal to 3/6. So I could think of this as 3/6 and then simply subtract that from, still taking away a half, but I'm thinking of it as taking away 3/6. I converted or changed my 1 1/3, just turned it all into 6 first, and then just subtracted the 3/6 from that. Very similar problem. What made this one a little bit different, and I want to think of this as just like method one way of doing this, and ooh, that was sloppy. And this is method 2. Okay, is that we took the half from the whole first and kind of added that on. It's just a kind of a different way of thinking of doing the problem. Okay, and that's all that is about. All right, now we'll go ahead and go on to, let's do another problem. The more practice, the more we do these, the easier it's going to get. So I'm going to kind of keep on cruising along. Now we have 1 3/4 minus 4/5. Again, representing this quantity first, that first number, because that is the number that is being subtracted. We're subtracting 4/5 from that total number, 1 3/4. I'm going to go ahead and let's get some quarters here then. I need this, and this I think will make our quarters. Yes, it will. Now, representing that, there's 1 3/4, and I'm subtracting 4/5. Well, again, I'm going to go ahead and make another model of this here so I can show that subtraction. So if I had that alongside here, one way I could do it, and let me go ahead and get a copy of that. Let me go ahead and put my quarters. I'm going to put my quarters for both of these. Okay, I'm putting quarters for both. It's still one whole here and my 3/4. So that part doesn't really change. Okay, and bring this down a little bit. I have my 1 3/4 right there. So now I have my quarters. However, I can't take 4/5 from that. But if I could, it'd make it so much easier. So let's go ahead and look and see how can we do that. Well, we could do that basically if we had some fifths, if there's a way we show fifths. Well, could we just simply say, well, yeah, we're going to show some fifths here. This would be a good way to show it, except you're going kind of like in the wrong direction here. Okay, we need that kind of cry. That way we have 1, 2, 3, 4, 5. Okay, now I'm going to have to spread this out a little bit, get it to work out here. That works for me. Boy, they're not the most even in the world, are they? Just now notice that. Let's just kind of assume, or I could do this actually. Yeah, that's okay. Just assume that these are all equal pieces, right? That would make it the easiest. So even though they don't look equal, this line should be up a little bit. The idea is that we have 1, 2, and thank you. We have 1, 2, 3, 4, 5, and then we have 1, 2, 3, 4. So we've now created 20ths. Okay? Each unit is 20. Now, if we take our 1 3/4, we can look at it. We have our 1 3/4. Now, I could just take the 4/5 right away, which is, since this is the fifths going this way, 1, 2, 3, 4, I could take just the 4/5 away from this. Now, before doing anything else, okay, and so that's 4/5 because we have 1, 2, 3, 4, and that would be the fifth one up here. So 4/5, and then I could just add on my 1/5 onto the 3/4, which is here. Which for this 3/4, you can see because we have 20ths, we really have 3 times 1, 2, 3, 4, 5. We have 15. So with 15 20ths here, and we add on that last fifth, and then I'm adding on that last 4 20ths, we have 19 20ths altogether. Adding those on. Now, the other way, again, this is method 2, which I want to show you really quickly. Take a couple of these here. In the meantime, let's go ahead and do the same thing and kind of shrink you guys down so it gives me a little bit more room. That's right, we'll get rid of you. You don't need you right now. Okay, so now the other way here is to go ahead and, again, showing our model. We'll take 2 of these. Again, we're just showing 1 3/4. And that's like looks like a half. There we go. Okay, so there's 1 3/4 was the, and then we're subtracting 4/5. So we want to go ahead and make this into fifths. And I'm going to actually do it this way. Okay, then that way you can kind of see them. And let me see if I can be able to do this. Group. That way I can take these and, oh good, I can get rid of that. Thank you, and copy. There we go. We're going to get ready to play tic-tac-toe here. Okay, so now we have our 20s. 1, 2, 3, 4, 5 times. Now, this is the other way that we could solve this problem that might make a little bit more sense for you. And that is that we have 1 3/4. Well, let's go ahead and put this in 20ths now. Since that's all of these, then it would make sense that 20 over 20 would equal 1 whole here because there's 20 of them. Plus we have 1, 2, 3, 4, 5 times 3, which means we'd have 15 20ths. Okay, I'm just showing this number here. Don't want to confuse you. 1 whole, 20 out of 20, and 3/4, 15 out of 20, giving us 35 20ths. Okay, 35 20ths. Now we're going to subtract. It says 4/5. Well, how much is 4/5 of this? Well, 1, 2, 3. There's 1/5. There's 2/5. There's 3/5. Here's 4/5, like the problem up here states. 4/5. Okay, right up here. Nope. Then, if we take and we look at this, we 1, 2, 3, 4, so we'd have 16 20ths. Now we're subtracting. Okay, and doing this here looks like we're going to have 15 minus 6, which is 9, and then that's going to be 19, so 19 20ths. We're getting the exact same answer, just showing it in a different way. Okay, and there's one more problem that I have. Okay, on this particular problem, I would actually encourage you to maybe putting the video on pause and trying to solve this problem on your own, and then playing the video so that you could see the rest of the problem to see how you did on your own. And so I will go ahead and show this. So 1 4/9 minus 1/2. So I'm going to go ahead and represent 1 4/9. And here's my 1 already. And then I'm going to show my 4/9, which here looks like be my 9ths, right? So this way I can come over here and say, okay, this 1, 2, 3, 4. Whoop. Let's do that again. Didn't like that bracket too much. Okay, new bracket. Okay, so there looks like 1 4/9. Okay, and then you see 1, 2, 3. Whoop, did I miss one? I did. And eraser again. Thank you. You surely come in handy, Mr. Eraser. Thank you. I appreciate that. Okay, so we're going to go all the way over to here. 1, 2, 3, 4/9. I'm going to go ahead and subtract 1/2. Well, I can't take halves from here, but if I were to put this in halves right away, that might make it easier. So I'm going to go ahead and show that by taking the halves here and doing this. Go ahead and show the other one in 9ths as well. That way I can see it. Now suddenly this makes it easier. I still have my 1 4/9 here, but it's made it easier because I have divided it in halves as well. So what I'm going to do here is I'm going to go ahead and show my 4/9 here to make it really easy to see. And of course this entire whole here shows my 1 whole. My 4/9 is listed here. Now we're coming in here and we're going to let's just use red. Okay, basically what am I taking away? I'm taking 1/2. So you can say, well, I'm taking away this half here. That's 1/2 of the amount right here. Now it'd be really easy since these have all been divided into 18ths because we had 9ths, but when we split this in half, we made double. Now we have 18ths. So when I think about my problem, I'm thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So now I have 17 over 18. Okay, and that showed the subtraction on just this one model here. So if you had that, again, you could have solved it that other method where you took the half away right away and then just added this onto what was left over. That was method 2. But basically that's it, my friends. And I'm going to give you the rest of the code word, which is going to be... Oh, all right, let's try that again. That's what I want. All right, my friends. Hey, it's been real. Adios.